Hi everyone, welcome to goclasses. Before we start this session, please let me know. Audio, video, volume, echo, everything is good. Let me know. Then let's start this session right away. All okay? Very good. Hi everyone, welcome to goclasses. In this lecture, we will discuss GATE CS All India Mock Test 3 questions. All the questions of my subjects, I will discuss the detailed solutions with complete analysis. I will discuss in this session. Okay. So this is GATE CS 2026 aspirants All India Mock Test 3 that we conducted for GATE CS 2026 aspirants. So All India Mock Test 3 AIMT 3 detailed solutions part 1. The remaining parts you can find in this playlist on YouTube. You can search goclasses AIMT. This you can search and you can find this playlist. Okay. In this playlist, basically you will be able to find all the video solutions, all the detailed discussions of all the All India mock test that we are conducting. Okay. Very simple. Before we start this session, let me tell you that previously few days back when we were streaming live streaming on the YouTube, then there was some issue with the YouTube and Zoom, and that is the reason our our live session got interrupted, and it got abruptly ended. Okay. So if you remember few days back when we were discussing AIMT 2, All India Mock Test 2, so there some problem was there with YouTube Zoom collaboration. Okay. And this was a problem on the YouTube side or Zoom side, and I am not sure whether it is resolved or not, but we have already raised our complaint. And if this session gets abruptly ended, then do not worry. Immediately, I will start a new session with a new software, with a different software. Without using Zoom, I will start with OBS. Okay, OBS. There is another software. I will use that software. Okay. So, so one very simple thing I am telling you that we will continue this session. If this session does not have any interruption, then it is a very good thing. Okay. But but by any chance, if there is any issue, okay, if this session gets abruptly ended by any chance, then don't worry. Immediately I will start a new session with a new software. Okay, and we will complete our discussion today. I will not leave any question, don't worry. Okay. So let's resume now. Okay, let's resume. So let's discuss GATE CS All India Mock Test 3 detailed solutions. Let me tell you that for GATE CS 2026 aspirants, this All India Mock Test 3 that we conducted in this AIMT 3, the number of live participants, that is more than 40 to 100. You can see this is the number of live participants. So I want to thank all of you for your trust in Go classes, that such a huge number, more than 40 to 100 students attempted AIMT 3 live. So thanks to everyone. You can see these are the numbers for AIMT 1, AIMT 2, AIMT 3 for GATE CS 2026. You can see in AIMT 1 it was around 3800, in AIMT 2 it was around 4000, more than 4000, and you can see in AIMT 3 it is more than 4200. So thank you all. And upcoming AIMTs, you can see for GATE CS 2026 aspirants, the upcoming AIMTs, these will be on Sunday. You can see every Sunday basically we have All India mock test. Okay, so the next Sunday, 11th January and 18th January, so we will have All India mock test. And if you want more All India mock test, even after 18th January, if you want All India mock test, then please let us know in the comments. Okay, and this is the schedule for gate da AIMTs. For gate da 2026 aspirants, we are conducting all India mock test. You can see so far two all India mock tests we have conducted, AIMT1, AIMT2, and now you can see these are the upcoming AIMTs. Every Saturday we have gate da AIMT, so it is very easy to remember. Every Sunday gate CS all India mock test, every Saturday gate da all India mock test. Okay, so don't miss. And one more thing, if you want to attempt all the previous all India mock test, by any chance, if you missed it, if you want to attempt all the previous all India mock test and also all the mock test in go classes test series, then we have launched full length mock test package. If you don't want to attempt the complete test series but you want to attempt all the full length mock test, then you can attempt and you can enroll in this full length mock test package that we have launched. Okay, so you can see for gate cs, for gate da, and for gate cs plus da combo. So what you can do, you can visit the go classes website, and on the go classes website you click on this button, this test series button you click, and then you can click on this button, you can see here. Okay, full length mock test package, and then you can enroll. So you can enroll for gate cs mock test, for gate da mock test. So these are the three options: gate cs plus da combo mock test. Okay, so let me tell you that gate cs mock test package, it has total 20 mock test including AIMTs. Gate da mock test package, it has total 15 full length mock test, total 15 full length mock test including AIMTs. And this combo cs plus da combo, it has total 35 full length mock test including AIMTs. Okay, now let's start this session. If you want more AIMTs, then please let us know in the comments after this session. After this session, you can let me know in the comments. Okay, so shall we start now? Now we are going to discuss many questions, the complete analysis of all the questions we are going to discuss. Okay, so be with me. Let's discuss all the questions. Take your copy pen. Let's solve all the questions together. I am solving, you solve. Okay, let's solve together. Let's solve this question from computer organization and architecture based on pipeline concept. So you can see, suppose we have a processor using 8-stage pipeline. If the computer has 2 gigahertz clock, how many nanoseconds does it take to complete each instruction once it enters the pipeline? Let me tell you, this is a beautiful question. Many students made silly mistake in this question, and this question is taken from a university, from a top university. You can see Carnegie Mellon University. From this university, this question as it is I have taken. I did not change a single word. You can see this is a beautiful question. That is the reason I have put it in our All India mock test. Okay, so did you solve it? Let me know. Did you make a silly mistake in this question? So let's solve it. You can see the question. What it is asking? It is asking that suppose we have a processor using 8-stage pipeline and the computer has 2 gigahertz clock. How many nanoseconds does it take to complete each instruction once it enters the pipeline? The question is asking that we want to complete an instruction. Once it enters the pipeline, then how much time it will take to complete that instruction? So please understand here, many students, what they did, they answered that, okay, that the answer will be 1 clock cycle. Then they computed the period time, I can say, of the clock. Okay, the clock period, and you can see basically 1 cycle time they computed and they answered it. Okay, so you can see this is actually wrong, because what this question is asking, this question is asking that we want to complete each instruction, but remember the question is asking how much time it will take for each instruction once it enters the pipeline. Means from the moment it enters the pipeline, means the stage 1, from stage 1 to, you can see, stage 8, from the moment it enters the pipeline to it completes, to its completion, total how much time it will take. This time this question is asking. Okay, one more thing, let me tell you that, see, pipeline actually, when you use the concept of pipeline in your processor, then overall what will happen, overall it will happen that many instructions, they will execute simultaneously in different stages. If your if some instruction is in stage 3, then another instruction will be in the stage 2, another instruction will be in the stage 1. So you can see many instructions, several instructions, they will be executing parallelly in different stages. But notice one thing, if you think from the particular instruction point of view, whatever instruction you take, from a single instruction point of view, from an individual instruction point of view, how much total time it will take once it enters the pipeline and to its completion. So that will be what, basically that will be number of stages multiplied by one stage time. And one stage time, that is your cycle time. Yes or no? So here what will be the answer? The answer will be basically 8 multiplied by cycle time. Okay, so here the answer will be 8 multiplied by, you can see, we have a clock. This is 2 gigahertz clock. So what will be the cycle time for one cycle? How much time? So that will be 1 divided by 2 gigahertz. Okay, 1 divided by hertz, that is nano. Sorry, that is 1 divided by hertz, that is basically second. 1 divided by hertz, this is basically second. Okay, and you can see 1 divided by giga, that is basically nano. Okay, so here what you got? You got 4 nanosecond. So this will be your answer. I hope you understood. Okay, very simple. So focus on this here. Once it enters the pipeline, once the instruction will enter the pipeline to its completion, total how much time it will take. Okay, so you can see from an individual instruction point of view, basically it will take 4 nanosecond from an individual instruction point of view. But remember, if you have 100 instruction and I want total time for completion of 100 instructions, then what will be the answer? Let me know. If I ask you, let's assume you have 100 instructions. Okay, then what will be the total time? Now you can see, because you are using pipeline, so several instructions, they will execute simultaneously in parallel in different stages. When an instruction is in the stage 3, then there will be another instruction in the stage 2, another instruction in the stage 1, like that. Okay, so you can see, if you have 100 instructions, then what will be the total execution time in this pipeline? What that will be? So you can see that the first instruction, remember, the first instruction, it will go through all the stages. Of course, all the instructions will go through all the stages. Remember, every instruction will go through all the stages. But the point is, when the first instruction is here, you can see this is S1, this is S8. Now remember, when the first instruction completes, then by that time the second instruction will be in the stage 7. Yes or no? The third instruction will be in the stage 6, like that. Okay, yes or no? So you can see that when this first instruction will complete, in the next clock cycle second instruction will complete, in the next clock cycle third instruction will complete, like that. Okay, so you can see, once this first instruction will complete, then after that, in every clock cycle one instruction will complete. Yes or no? So you can see that I can say this first instruction, it is basically taking total 8 cycles. Okay, plus remember, every individual instruction is actually taking 8 cycles. But the point is that when this instruction will complete, this first instruction, when it will complete, then after that, in every clock cycle one instruction will complete. So you can see the remaining 99 instruction, they will basically complete in every consecutive cycle. Yes or no? Okay, so like that. So finally you can calculate your answer. That will be 99 plus 8, and that will be 107, these many cycles. Okay, here also please understand one thing. Individually, one instruction is taking how much time? An individual instruction time. This is called instruction latency. Instruction latency. So what is instruction latency? This is the individual instruction execution time. This is the individual instruction execution time. Tell me, what is that? Individual instruction execution time. What is that? That is number of stages multiplied by the cycle time. Yes or no? Or I can say that 8 cycles. Is this point clear? Let me know. Very simple. I hope you understood this. Remember, instruction latency, that means individual instruction execution time, and individual instruction execution time, that will be 8 cycles, because every individual instruction has to go through all the stages. So once the instruction will enter the pipeline, then to its completion, total how many cycles it will take? Total 8 cycles it will take, because it will go through all the stages. Very simple. I hope you understood. Okay, these nodes you can see here. You can see the instruction latency. What that instruction latency means? This is the delay when this input is submitted, when this input enters the pipeline until its completion. Okay, very simple. So this is called instruction latency. And you can see what will be the instruction latency in a k stage pipeline. You can read this. The latency of a k stage pipeline, that will be total k cycles, or I can say that k multiplied by the cycle time, yes or no. So you can see the latency of k stage pipeline, that is k times k multiplied by the cycle time, or I can say the period of clock common to all the registers. Okay, very simple. I hope you understood. You can see. And what is throughput? Throughput means per second how many instructions are completing. Okay, per second. You can see throughput. Throughput simply means that per second, per second, how many instructions are completing. How many instructions complete. Okay, so tell me what will be the throughput in this question. In this question, if I ask you what will be the throughput, if you have 8 stage pipeline, 8 stage pipeline, remember the throughput. What is throughput? Throughput means per second how many instructions are completing. Per second, how many instructions completing. How many instructions complete. Okay, so you can easily see that overall, if you notice, if you have, let's assume, large number of instructions. Okay, when we calculate the throughput, then basically we assume that large number of instructions we have. Okay, so remember this throughput, when we calculate, then we assume that we have large number of instructions. Remember, throughput is calculated basically when you assume that you have large number of instructions. A large number of instructions are executing. Okay, so here what will be the answer? You can see that one instruction completes basically in one cycle, yes or no. So remember, it one instruction completes in one cycle, or I can say that one cycle means one instruction. Okay, so I can say here that what is the cycle time? Already the cycle